Good morning, everyone. Hello, am I audible? Just confirm me in the comment section. Hi, this is Sharda, and I'm going to take your workshop on customer segmentation using unsupervised machine learning. So, I would like to welcome you all for this project oriented hands on workshop. So first of all, we will understand basic agenda of today's workshop and what you are going to learn during this workshop. Okay, so the basic prerequisite for this workshop is some basic knowledge of Python, and if you know something about the machine learning, then it would be more beneficial for you. And during this workshop, we are going to do the customer segmentation for targeted marketing. And we are going to use unsupervised machine learning clustering algorithm, as well as we will use PCA for the data visualization, and we are going to use scikit-learn Python library, matplotlib library, seaborn, pandas and numpy. Okay, and this task we have divided into different steps. This project we have divided into different steps. So I'll discuss all these steps during this project implementation. And don't worry, this is totally practical oriented workshop. In this workshop, we are going to do all these things practically hands-on. And you don't need to worry about any software or installation part. We simply use Google Colab during this workshop. Okay? And if you have any question regarding this workshop title or concept, you can ask me in the comment section. I'll answer your each and every question during the workshop only. Okay, so let me give you the brief introduction about the workshop again. Like, this is unsupervised machine learning algorithm implementation for customer segmentation. You know what is the segmentation? Basically, in the segmentation, we divide the things, separate out different things, we make the groups. So we will train an unsupervised machine learning algorithm to perform bank customer segmentation. This project could be practically applied at any marketing department in banking and retail industries to segment customers into clusters or groups. Okay, and in this project you will go through these different steps. First of all, we will understand the problem statement, what is basically problem and business case we are going to implement, and in the second step we are going to import the necessary libraries and the important functions and data set. After that, the important step of the any machine learning algorithm is visualize and explore your data set. You should know what is in this data set, particular data set which we are going to use. And then we will understand the theory and initiative behind the k-means clustering machine learning algorithm. We will understand the basic theoretical part of k-mean clustering, how does it works. And then we will see the elbow method. Elbow method to obtain the optimal number of clusters using the elbow method. Like how many clusters you need to take you want to categorize the customer into 2 segment, either 3 segment, 4 segment, and n segment. This we will select with the help of elbow method. And in the next step, we use scikit-learn library to implement the clustering algorithm. And we will apply PCA algorithm also to visualize the data set. Basically, PCA is principal component analysis technique to perform dimensionality reduction and data visualization. Okay guys, so hopefully now you are aware with what we are going to learn at the end of this workshop. You will be able to complete a project. You will get the experience of a project of unsupervised machine learning of customer segmentation. Okay? Like this project is extremely important. You guys can directly apply to it any marketing department in banking sector or retail industry. Even you can add this project to your portfolio of projects, which is essential for your job interviews. Like when you are going to sit for any job interview, you should have some project completion. And the practical part we are going to use, like software part, we are going to use here the Google Colab. And for the Google Colab, you don't need to worry about the installation part. You can directly use the Google Colab, it already installed. Most of the software part, it already installed. It is a powerful Google Cloud. You can get the privilege of Google GPU. It is a pre-configured cloud desktop cloud with all the software that you need. Okay? So simply you can put, you don't have to worry about any installation or just any headaches. Just go ahead and follow along and code with me. And please note that this project is a beginner to intermediate level project. It has some prerequisites. It basically requires basic Python programming, I already told you, and basic knowledge of machine learning as well. Okay, so let me open Google Colab, how to use the Google Colab. Let's go ahead and open your any browser, and here you need to type Google Colab. Okay, just I have typed the Google Colab, and here the first link appears, Google Colab. You need to click over here and you will be redirected to the Google Colab. Some of you already know about the Google Colab. If you are new about this, you can I'll just give you the brief overview how to use the Google Colab. This is very easy guys, and like if you used once the Google Colab, you always prefer to use the Google Colab. And then here you can open the new notebook, and if you have already Jupyter Notebook code, you can upload here the file. You can use the file from your Google Drive also. And whatever the Google Colab files you have, you can see the list here. Okay, so I'm just opening my existing Google Colab, or I can open a new Jupyter Notebook. You just need to log in with your Gmail account. It is asking for you to log in with your Gmail account. That's all, nothing else. So here I can write the Python code and I can develop any machine learning algorithm here. Okay, so simply I can write a simple line of code, print, and then the hello. Okay. No guys, Python ideally is you can use, but I never prefer this because this will show you different things, graphs, and in the Python ideally you need to install certain libraries. You can install that, you can use that, and you need to install certain libraries. Here you don't need to install anything. That's your choice. Okay. Now what I will do here, I will develop my project here. Okay. So in this project, you can assume that you have been hired in a bank as a data scientist. And what the bank wants from you, bank basically wants you, bank will provide you a data set and you need to segment the customer from that data set. Like here we are going to use a data set that is you can take from the Kaggle. I'll show you the link and I'll share with you also this link. Like the data set which I'm using from the Google Kaggle, you can download this data set from the Kaggle, as well as I'll share with you the CSV file. Okay. So let me give you in the comment section. Yes, you can download the dataset from this drive link, or either you can download the dataset from the Kaggle site. Basically, what is the dataset here? What the dataset we are using? We are taking a dataset of a particular bank. A bank's 6-month credit card holders dataset. So this case requires, here you can click over this link and from the Kaggle you can read this description. Like this case requires to develop a customer segmentation to define marketing strategy. This data includes like transaction frequency, how frequently a credit card holder is doing the transactions, and this how much amount is paying, how much balance he or she will keep, and different parameters. Like we have data of 9,000 account holders and last 6-month data, and this data have 18 variables. I can zoom out this. 18 behavior variables. These 18 variables are called the 18 features. Okay. So what are the 18 features here, guys? You can see we have different things. First is customer ID, identification of a card holder, and then the balance, and then the balance inquiry, how frequently the balance is updated. Like if a score is near to 0, it means not updated, and near to 1 is means it is frequently updated. Okay, and then we have balance frequency, purchases, one-off purchase, maximum purchase amount done in one go. So according these things, we will divide the customer into different categories. The bank marketing team would like to take a benefit of ML algorithm to launch targeted marketing ad campaign that is basically designed to target a specific group of customers. Okay, like this campaign should be successful if we divide the customers into different categories. Marketing segmentation. What is the marketing segmentation? Basically, marketing segmentation is dividing customers into different categories. and it always maximizes the market campaign conversion rate. Are you getting the things? Yeah, just wait, guys. I'll tell you about the certificate also. This is a like you we will provide a Google Sheet and you need to fulfill the details there. Okay, and we will verify your presence 2-3 times for the certificate. Okay, so here you can see different parameters of the customers we have. So according to those customers, according to this data set, we need to divide the customer into different categories. Okay, this is the first step. First step is to understand the problem statement and the business use case. So our problem statement is market segmentation. Customer segmentation according to the need. And these are the different parameters of dataset we have. We need to download this dataset. Either I have already downloaded and provided you to CSV file. You can use that file or you can download this from the Kaggle. Okay. Basically, if you study about the basic things about the customer segmentation, you can see there are the 3-4 type of customers. Which customers are more important to bank to review their credit scores and to check their spendings. All these things need to check out. Like we can divide the customers into 4 categories. I can tell you. Steps you already know. Okay. You can write down these steps. I'll just open a new file and here I'm just writing the type of customers. Like broadly we can categorize customers into 4 categories. One is transactors. And the second category is revolvers. And the third category we can include new customers. And one category we can include VIP or prime customers. I can define these. You can search over the Google. You will find out the broad category of customers. One is transactors, customers who pay the least amount of interest charges and careful about their money. They spend very less, they give very less interest, they are more careful about their money. They always check their account, they never keep any due. These are the transactors. And the second type of customer is revolvers. Revolvers customer who use their credit card as a loan. This group is most lucrative sector for the bank since they pay 20% interest. Okay? And new customers, new customers with the low tenure who can be targeted to enroll in other bank services. Like their tenure is always less than 5-6 years. And VIP is with a high credit limit. They have much credit limit. And they do the full payment and they can be targeted to increase their credit limit on spendings. Like you can say the person who are using more credit card, they have more balance. Right? So we just want to find out these 4 type of customers from our data set. Are you getting the things? Okay, now I'll just open my Google Colab, and here I need to upload the file, and then I'll start the execution of this project. So you can upload your data set here. Here you can see the left side, we have icon of file, and here you can upload a file. Like go to there, and there is marketing underscore data. This data set I have downloaded from the Kaggle. I have provided you to link also. Okay. Yes, I'm moving ahead. Some people are joined now. I'm just telling you the steps. Okay. So you can just simply upload the data set here. Okay, this is my data set. If you are facing any problem in downloading the data set or uploading data set in the Google Colab, you can put a question in the comment section so that the other people who have already done can help you, or either I can help you. So marketing data, this is my data set, and the task one is to understand the problem statement. So I think you got the brief idea about the steps, about the project problem statement which we are going to solve in this project. Okay. So here the step 1 we already completed. Step 1 is understand problem statement. Okay, now I'm just going to execute the step 2, that is the import the necessary libraries and data set. Just code along with me so that at the end of this workshop you will got a complete project with you, and you can add this project to your resume. Okay, so here I'm just going to import the necessary libraries. First of all, I'm importing the pandas library. Import pandas is pd. Pandas library is used for data analytics. And the second library I'm importing here, the numpy library. Numpy library is basically used for the numerical calculations. We can do the big numerical calculation very easily with the help of numpy library. And the next library I'm importing here, the Seaborn. I'm just zooming out my screen so that you will see clearly. Okay, now it's big enough. Import Seaborn to plot the different 3D plots. You can plot with the help of Seaborn, and we are also going to use Matplotlib. Matplotlib is to plotting 2D graphs. Okay, and the machine learning library, one library we are going to use here, sklearn. So sklearn, we are importing here the sklearn. Sklearn is a library that have different inbuilt different machine learning algorithm inside it. Okay, so import sklearn dot preprocessing I can take like this, from sklearn.preprocessing import, in place of import, from sklearn.preprocessing I'm going to import standard scaler Don't worry, I'll explain each and everything whenever we will use these things. Here I'm just importing the libraries. Normalize, and little bit I'm explaining along with this also. So standard scalar, this is for normalizing your data set. Like data set in a different range, with the help of a standard scalar, we can normalize our data. And for the clustering, to implement the clustering algorithm, here we are importing sklearn dot cluster import k-mean. K-means, this is inbuilt library to implement the k-means algorithm. And from sklearn, I'm importing PCA also. sklearn dot decomposition you can see here Google Colab also provide you the help. Like when you are typing the first letter, it will show you the related package names. Import PCA. Okay. So these are the libraries I'm going to use during this project. Mostly I have imported in this step. And you can also set the Jupyter theme or whatever you can like according to your choice. But these are the necessary libraries. Okay. Now what I need to do, I need to use the data set. I need to import the data set, read the data set. So with the help of pandas library, I'm going to read the CSV file which I have uploaded here, marketing_data.csv. Okay. So you have to include this data file. If you are using any ID in your computer, then you need to provide the link of that file. You need to provide the full link to the CSV file that containing your data set. So here I'm reading this file like credit card data frame df. I'm giving the name credit card df, and pandas object is pd dot read underscore csv, and inside the bracket I need to provide the name of this file. So what is the name of this file? Marketing_data.csv. Here I don't need to provide any path because this is in my current folder. Marketing_data.csv. Okay. I'll run this code by hitting the shift enter. And I have read the CSV file data, and data is stored inside this data frame credit card underscore df. And you know, I have already told you the description about the data set. So the different field, it have 18 columns of data set. So don't worry about this. We will see the data set here. We will print the data set. Some people are asking a question like, I don't have any prior knowledge of unsupervised learning. Can I proceed? Yes, guys, you can proceed. I'm explaining each and everything from the very scratch. Simply, you just know the basic knowledge about the Python. Okay? Just follow along with me. You will get the things. Okay, until now if you are facing any issue, you can post in the comment section. Otherwise, I'm just supposing you are doing the code along with me. And if you are coding along with me, then only you will complete this project at the end of this workshop. And you feel the proud you have completed one project of machine learning. Sometimes some people study this during a complete course and they were even not able to complete the project, and you will do the complete project during this 3-hour workshop, 3 to 4 hours. So don't worry, do along with me. We are reading the data set that is inside the marketing_data.csv. Okay. Now we will print this data set. credit, you can see here the variable name also it is popping up. So I can select here credit card underscore df and I can run this. Either you can write credit card underscore df dot head. So dot head 5, it will show you the top 5 records, and if you are writing directly variable name, then also it will give you the top 5 records and the bottom 5 records. And in the bottom you can see we have total data of 8,950 rows and 18 columns. What does mean? We have data of 8,950 customers, and with the 18 columns, like 18 different features like customer ID, balance frequency, purchase transaction and credit limit, payments, minimum payment, tenure, all these things. Either you can see here, just a second, either you can see here by scrolling, like here the column headings, like customer ID, first column name is customer ID, then we have balance frequency, purchases, all these things we have. So total we have 18 columns. Okay, so this is data set we are going to analyze, going to use during this project. Now you should clear with the data set. Or we can get the more information about this data set. Let's apply the info function, like credit card underscore df dot info. This is a function of data frame, and if I'll write this function and then hit the shift enter, you can see the output. In the output, you will get the additional insights of our data frame. Like this is a pandas data frame. You can see what type of this variable. Credit card underscore df is a variable that is pandas data frame, and range index it have 8950 rows, and the total columns we have 18 columns, and you can see the column names. These are the column names from 0 to 17, and additional information about the column like not null. Like some columns total rows we have 8950, some rows don't have any null value, and like this column you can see 8949, here we have one null value. You can see 8637, here we have some null values, right? And the data type about every column, you can get the data type like this is an object data type. Object is string kind of data. And the float data, we have float 64. Integer data, we have int 64. You can see the data type, you can see the column name, you can see the not null values, all these things. And total memory size it is taking, and the different data types we have using here, the 3 data types. So this is the additional insight about our data set. This session is around 3 to 4 hours. Like I'll try to complete in between the 3 hours. It may take 3 to 4. Okay guys? So this is the details about the data set. Now I have a question from you guys. I have a question from you guys. Like I got a information about the data set. Like what is this data set? I have used the info function. Similarly, you can use another functions of pandas. If you know about some functions, like you can get the average, minimum and maximum balance amount. Like I'm just giving you a question, a challenge question, or you can say a simple question. I'm writing here a question. You guys need to try to solve this question. Otherwise, I'll tell you within the minute what is the average, minimum and maximum balance amount. This is a question I'm asking from you guys. Balance is a column. You can see second column is balance. You need to get the maximum value, minimum value and average value of balance column. So if you know something about the about the pandas, you can give me answer in the comment section how to get the maximum and minimum and average of particular column from a data frame. Otherwise, I'll explain the answer. Don't worry. If you don't know anything about this, then don't worry. Okay? Come on guys, I'm expecting a answer from you guys. What you need to do, you need to calculate the average, minimum and maximum of a particular column from the data frame. I'm expecting answer from some of you, at least. Just give it a try. Otherwise, I'll tell you the answer. What we can do here, credit it like credit card DF. This is particular data frame, and if you want to access a particular column, you need to write the column name inside the square brackets, inside the single quotes. So here the column which I want to access is a balance. I want to access the balance column and I want the mean value of the balance column. So dot mean. And now I can run this and you can see this is the average value. Average value of the balance. Similarly, you can get the maximum and minimum values. Max. Okay? Are you getting the things? So we can get the maximum balance and minimum balance. Okay? So this is the simple question, like how to work with the pandas. Now you can use the another function like credit DF, credit card data frame, and let's scroll down. Dot describe. Describe is a function. This will give you the more statistics inside our data frame. Like I can run this and you can see here the output. We will get the mean value, we will get the max value, we will get the count, mean, standard deviation, minimum 25%, 50%, 75% and maximum values of a particular column. So you can see here the mean balance is 1564. Balance frequency is frequently updated. Like here we have value near to 1. So 0.87 means we can say frequently updated. And purchase average you can see 1000. And one of purchase is average you can say it's around 592. And average purchase frequency, you can see installments purchase is 411 and purchase frequency is 0.5. Okay, so like this we are getting average values, maximum value, minimum, like most of the statistics we are getting here about the data set. Now if I'll ask a question from you guys, like you want to obtain the features of a customers who made the maximum one-off purchase. Like we want to get the customer ID. We just want to know the customer ID of a customer who made the maximum one-off purchase. I want the customer name, customer ID, whose one-off purchase is maximum. So you can see here, one-off purchase maximum is 40761. So we want to get the person whose one-off purchase value is 40761. Okay, so you can give me answer in the comment section, otherwise I'll tell you the answer. What is the question? Question is, I'm typing here the question. I want to know the person whose purchase is maximum. The customer who made the maximum one-off purchase. One-off underscore purchase. So what we can do here, credit and from credit DF we need to get the person whose one-off purchase is equals to 40761.25. So inside this, one-off underscore purchase one-off underscore purchase equals to 40761.25, right? What it will give you? True and false. Like if this condition is satisfying, then true, otherwise false. I just want the customer, then I need to pass this condition from this data frame. Credit card underscore DF, and inside the bracket I need to pass this condition. Now I'll get the particular person. Getting? Yes, I got the correct answer from Om Prakash Kumawat. No, Om Prakash, this is not the correct. You can see my answer. Okay? Similarly, you can do the different data operation. Like you can obtain the features of the customer who made the maximum cash advance transaction. How many cash advance transaction did that the customer make? How often they pay their bill? So cash advance is also a column. We can see the maximum cash advance, like who is paying the, what is the maximum cash advance, and then we can get the person whose maximum cash advance. Similar thing, like one off purchase, we can get the cash advance also. So second question I'm leaving for you. You need to get the features of the customer. You need to get the customer who made the maximum cash advance transaction. And how many cash advance transaction did that customer make? Like I'm writing here credit DF card, and one column is cash advance. Cash underscore advance, and I can see the max value of cash advance using the max function. Okay, and this max value I'll use like this credit df and then credit df, and inside the bracket I can pass the cash advance, and cash advance equals to this amount. I can copy and I can paste here and I can run. I'll get a particular customer. Okay, so this is the simple concept I'm telling about the pandas. Now move ahead and we will see the third step, visualization, and we will explore our data set. So this is the simple. We have imported all the necessary libraries. We have completed 2 steps till now. First is understand the problem statement, what the problem we are going to solve during this project. And the second step is like what the data set we are going to use, and then there's some to load the data set and view the data set. Now in the third step we will visualize and explore the data set. Okay, so step 3 is visualization of data. Data set. Visualization of data set. So for the visualization, what we are going to use? We are going to use matplotlib library or Seaborn library. Okay, so first of all we will see the Seaborn heat map. Okay, so don't worry if you don't know anything about the Seaborn. We have already imported the Seaborn. Import Seaborn as SNS. In the step 2 we have imported the Seaborn. Right? Now I'm just going to use the heat map function from Seaborn. SNS dot heat map, and inside the heat map what I am writing here, my data set inside the credit card df, this is my data frame, and I'm just checking is null. If any data set is null, then I'll plot here, and meanwhile what I just want to plot y-tex And color bar I'm taking here. White tick labels I'm writing here false, and color bar you can take the false. C bar is equal to false, and color map I can take C map is equal to blue. Okay, now I can run this and you can see the plot here. Like Y ticks I have off, Y label I have not provided, X label you can see are columns. We have total 18 columns, you can see here. So in the graph you can see customer ID, balance and frequency purchase, all these things. The third last output you can see here. Third last is minimum payments. In the minimum payments we have lots of bar. Means in the minimum payments we have null values. Okay? So this plot shows you the minimum labels have null values. So we need to treat, in the machine learning, what we need to do, before feeding the data to the algorithm, we need to refine the data. We need to remove the nulls, we need to remove the repetitive values, and we need to normalize the data set before feeding the data to the actual algorithm. So we are doing this pre-processing part. Okay guys? Are you getting the things till now? Just give me a quick confirmation. Netik is asking a question. Can you explain the y-ticks? Y-ticks label basically, Netik, we are not using here. You can see in the only the x-axis I'm getting the labels. These labels, but in the y-axis I'm not getting any label. Okay? Okay, and LOC, ILOC I'm not using here. When we will use, I'll explain. There are the lots of functions inside the pandas. Okay, so now I'll check it how many null values, like total sum I'll check. So credit card underscore df dot is null dot sum. So I'll sum the values and null value sum. So you can see here the output is credit card df dot is null dot sum. So the column wise null value sum, you can see we have one null value in the credit limit and 313 null values in the minimum payments. Okay, so now what next we will do, go ahead and replace the missing values. So we will replace the missing values with the mean values of that particular column value. Like in the minimum payment, we have 313 missing values. So what we will do, we will fill up the missing values with the mean value of this minimum payments column. Credit card df. Here we are going to use the LOC. LOC is for to access a particular row column, like particular element you want to access, and you are providing the index for the row and column. So dot LOC, and inside the bracket I'll just use the column. So I'm writing here credit card DF, and from the credit card DF, which column I want? Minimum payments. So I want this minimum payments. And minimum payments, I don't want to replace the complete column. I just want to check the null values. Is null equals to true? In this column, wherever I will find the null value, I'll replace that value, okay, with the mean value. Okay, so this is the particular row I need to tell, and the column I'm using the minimum payment only. Minimum underscore payments. Okay, this is the location, this is the row and column I just want. Equals to, replace with mean value of minimum payments. So credit card underscore DF, and column name is minimum underscore payments dot mean value of this column, replacing with the credit card DF minimum column mean value. And which value you are replacing? The row is where we are getting the null value in this column, and comma column is minimum payments. Okay, I'm running this code. Okay, so now this is replaced. Now you can see again, you can calculate the credited null values. Credit card DF dot is null dot sum. You can see now in this minimum payments column we have 0 null values. So the next task is yours. Fill out the missing elements in credit limit column. Now this one you need to do. Credit limit column. This is one missing value you need to fill out. And you need to check out. After this we will check again there is any missing value present or not. So the question I am providing you, fill the missing values in the credit limit column. Okay, what you can do, you can simply copy the previous code and change the column name only. This code, I'm copying this code, and then in place of minimum payments I'm changing the credit limit. Credit underscore limit. Here also, and here also. And now I can run this code. And after this, we can cross check. Like we can check the cross check with the help of heat map also. Like again, I can plot the heat map. I'm just going up and copying the code for the heat map. This one. Now I can run this code again. Copy. And here I'm running this code again. And this time you can see the plot. There is no null value. There is empty output, empty plot means no horizontal line. Here all the values is filled. No null value. This is for checking the null values and filling out the null values. Next step is to check the duplicate values. So let's see if we have duplicate entries in our data set. Okay, our data inside the credit df dot, we have function duplicated dot sum. Now I can run this and this will give you the output. Here output is 0 means we don't have any duplicate value. Dharmendra, what you are not understanding, not getting your point, which code you want to explain again? Like just I'll give you the recap what I am doing here. Just listen to me carefully. Like what I have done till now, the step 2 I'm doing. First step you already know. Step 2 is I imported all the libraries and then I'm reading the marketing underscore data CSV file, and from this data I'm checking the info and then the describe function I have used, then min max values I have checked. After that I was checking like there is any null value or not. To visualize the data set. Visualization of data set. Here I am using the heat map. Credit card DF is data set we have, and then is null. We are plotting the values is null values from this data frame. And white text we are false and color bar false, and C map we are using blue. And then what we are doing, this null value we are searching how many null value, and then null value we are replacing with the current value, with the average value. How we are replacing the value? Credit card DF, this is a data frame and we are using here LOC function to access a particular values. So credit card underscore DF dot LOC, and inside the LOC we need to provide the row comma column. So inside the square bracket we are providing two things. The rows like credit card underscore DF minimum payments. Minimum payments is null. Wherever minimum payments is null equals to true, and the column is minimum payments only, comma column. Equals to, we will fill this value with the credit card underscore DF minimum payments dot mean value. Okay, and then we are checking the sum. Okay, here we are getting sum of only for the credit, only one null value, that is for the credit limit. Okay, Dharmendra is asking for 19th block. 19th block is nothing, it is the same as the 17th block. In the 17th block, we have replaced the minimum payments column null value, and in the 19th, we have replaced the credit limit column. So in place of minimum payments, we have replaced here the credit limit. Credit card.df.loc credit df credit limit is null. Wherever the credit limit is null, we will replace this by the credit limit average value. Okay, and then we are plotting again heat map, and heat map is blank. There is no null values. After this, we are checking the duplicate values. Credit card underscore df.duplicated.sum. There is no duplicate value. Okay. Next step, we will need to check out like standard scaling or some other things in the data. Like we just want to drop a particular column. Like here, the first column is customer ID. And you know, customer ID is a string value. We are not interested in the customer ID. We are interested in all these other fields. So we just want to drop this customer ID. So how we can drop a particular column? Just a second, guys. This is the code for 19th line. I have already pasted you in the comment section. You guys can see that. Okay. Now the next thing is I just want to drop a particular column. Okay. I just want to drop the customer ID. First column. For that, I can use the drop function. Like here, I'm writing credit card df dot drop, and inside the bracket, I need to write the column name. Column name is cust underscore ID. And I want to delete the complete column. So here I need to write access is equal to 1. And then I need to write in place. In place is equal to true. And I can run this code. Here what the in place will do, if I don't write the in place is equal to false, then it will drop that column in this particular case, not in the complete memory, not in the complete original data set. For this particular case, it will delete, but I just want to delete from the memory, from the actual data set. So that's why I have put it here in place. And now you can print the credit card DF, and you can see here we have only the 17 columns now. In place of 18 columns, we have only the 17 columns. First column now is balance. Before that, when we seen this data, the first column was the cust underscore ID. So now we removed one column. Okay. Now you can see we just want to check our complete data. We can check the length of our total columns, name of total columns. If you want to check like length credit card underscore df dot columns, and you can print this. Length of total columns is 17. And I can print the column name also, credit card df dot columns. You can see here the list of name of columns like balance, balance frequency, purchases. All these are the column names. Okay. Now we can plot one more type of plot, that is the dist plot. Dist plot is basically we can see the histogram as well as the KDE plot. Dist plot is basically combination of matplotlib hist function with the seaborn KDE plot. KDE plot, don't worry, I'll explain what is the KDE plot. KDE plot basically represent the kernel density estimate. Like I'm writing here in the comment section, we are going to plot dist plot. Dist plot is a combination of matplotlib dot hist function and seaborn KDE plot. So dist plot is a function of seaborn. And what is the KDE plot? Basically KDE. KDE is kernel density estimate. Or you can say KDE is basically used for visualizing the probability density of a continuous variable. Probability density of a continuous variable. We will plot it. You will understand in more detail. Are you getting till now the things? Like we have done such some operations over the data set. Now we just want to visualize our data set with the help of KDE plot. KDE or histogram, that is we are going to use dist plot. Okay? Like here, I can write KDE for visualizing probability density of a continuous variable. Or you can say KDE tells the probability density at different values in continuous variable. Let me plot. Just go ahead and plot these things so you will understand in more detail. For I in range. Here I just want to do this task for every column. So how many columns I have here? 17 columns. So I can directly write the 17, or either for the generalized form I can write length of credit card df dot columns. Okay, I will run this loop for every column. Okay, so here PLT, I'm just going to plot a subplot. PLT dot subplot. And inside the subplot, I'm just going to write 17 subplots I want, and I plus 1. What is the subplot? I think first number of rows. I just want 17 rows and number of columns, and then the whatever I am taking in every column. And then SNS dot dist plot, and here I'm taking credit card df, and from the credit card I'm taking the columns. So credit card, inside the credit card df, I'll just pass credit card df dot column, particular column, df dot columns, and I'm taking ith column. Okay, this is the x-axis, and y-axis I'm taking KDE underscore KWS, and here we will provide the color KWS is equal to color I'm taking blue, B for the blue, LW, line width I'm taking 3, and the label I'm taking KD. Okay, and hist KW, don't worry, you will learn after some time, because these are some plots, little bit advanced, but right now you can listen to me and you can make the plot, and after this you will understand each and everything. Okay, and then I need to write plt dot title. Title I'm taking the column name. So credit card df dot column I. plt dot tight layout. I can run this. There is some warnings. Let me check it out. Okay, this is overlapped now. I'll write here. plt dot figure FIGURA. Figure I'm taking the figure size because it's overlapping. Fig size is equal to 10,50. Now I can run this. I'll tell you a little bit things about detail. Yeah, these are the basically, you can see we have two things. These are the plots. For every column we have plotted. You can see that carefully. These are the beautiful plots. For every column we have. Like first is for the balance. You can see the green one is for the histogram, this is the histogram, and this is for the KDE map. So for the balance, you can see the average value. It's around 1500 something. Maximum peak value is 1500. Similarly, for the balance frequency, it's near to 1. And for the purchases, we have these values. Like this, we have, for every column, we have this plot. Okay? This is only for the visualization. This is not important. Like if you don't make this graph, then you cannot analyze the data. You can analyze the data. This is just for your understanding. Okay guys, can you give me a quick confirmation? Because from your side, I'm not getting the response. Give me a quick yes, you are getting the things or not. Write in the chat window. Otherwise, I'll give you a question. You have to solve that. Okay? Okay, now I got some responses. Okay, you are listening to me. Now the one important graph I'll show you, correlation matrix between the features. Like when you don't, you are not a domain expert. You are not from banking side. You cannot like see this data is important, this data is more important, this column is less important. You cannot say. For that, you can obtain the correlation. So obtain the correlation matrix between the features. And how to obtain the correlation? We can use the heat map. Okay. We can use the heat map. Basically, heat map will tell you the correlation. Correlation matrix between features. Okay. So how to get the correlation? There is a function CORR. So correlations is equal to credit card underscore df dot CORR. Okay. And then I can plot the heat map. SNS.heatmap correlations comma and not is equal to true. This is the simple. Correlations is not defined. There would be a typo mistake. Equals to, I need to write here. Equals to. This is the heat map, but you cannot view clearly. So I can write here the subplots. Like I can write here f comma ax is equal to plt dot subplots and figure size I'll increase. Figure size is equal to 20, 10. Now I think it would be better. Yes, clearly you can see. This is the heat map, and you can say this is the correlation matrix. Here in the x-axis all the columns we have, and in the y-axis we have all the columns, right? The any column having relationship with correlation with itself value is 1. When value is near to 1, then it have more correlation, and if value is near to 0, it have less correlation. So you can see here the purchased this third value, like 0.92, this value, you can see this value purchased versus the fourth column is one of purchase. One of purchases and purchase have more correlation. Their value is 0.92. Similarly, 0.86, here you can see purchase frequency have good correlation with purchase installments frequency. So like this you can see from this matrix. Okay? Okay. I'm watching meanwhile the comments. Some people who are like already get the things, you can give the answer to the other persons, and it's a little bit difficult in meanwhile to see the comment. Otherwise I'm watching your comments also. So Dharmendra have written पिछला समझ नहीं आया. Dharmendra, just don't worry, you can focus on this one because I cannot repeat again and again. Last one is little bit tricky, that is the dist plot. After the class you can revise one more time the video, you can watch the recorded video one more time. This is simply I'm visualizing the data with different functions of Seaborn library and Matplotlib. First time this is a little bit difficult for you, but don't worry, just try to cope up as much you can do. Because if you are new to the machine learning, then it is little bit difficult, but after this time you only listen to me, and after the class you one more time you listen the video, then you will get each and everything. Okay, and this is the heat map. You got the heat map. Heat map means basically we are getting the correlation. This is not for one person workshop, Dharmender. You need to focus over the class. You need to take care of other persons also. If your getting power is less, then just watch, listen to me, and after the class implement this. We cannot go with the one person. Or we are providing reply of every answer of every question. We cannot say, we cannot write code in your system, but we are providing the answer of every question. These are not the question. You are not getting things, you are a little bit behind, all these things. Next thing is, we got the correlation, and after the correlation, now we have analyzed our data in different ways. Now we can use this data. Okay, understand the k-means algorithm. Now I'll tell you the next step number 4 is k-means algorithm. Okay, so we will understand the concept of k-means algorithm. You will got the notes from our website of this workshop. So after the class, you can revise the notes as well as video. step 4. Step 4 is k-means algorithm. So now I'll explain you the basic concept of k-means algorithm, how the k-means algorithm works, and understand the theory and initiative, the intuition behind the k-means. Okay, so just open goeduhub.com and then type here k-means algorithm. K-means algorithm, and you will see what is the k-means algorithm and how does it works. Let me check it out. In the machine learning, you can go in the machine learning. I'll give you the link, just wait. And unsupervised machine learning, k-means algorithm. Now I'll explain the concept of k-means algorithm. And I'll give you the link of this article. What is the clustering? How the clustering works? And what is the unsupervised machine learning? Okay, so let me explain you. You guys open this link. Okay, and first of all, what is the unsupervised machine learning? Like in the machine learning, we train the machine with the help of data, and in the supervised machine learning, we have input features as well as we have labels. Like if you want to classify the fruits, so you have the fruit feature like color, shape, size, weight, as well as fruit label, previously, and you want to train the machine, you will train the machine with the help of feature, like feature, if fruit is red, fruit is round shape, fruit have weight like this, then it is an apple. So you train the machine with the feature as well as the label. The output previous already. So that is the supervised machine learning. In the supervised machine learning, we train the machine with the input as well as with the output. That is called the label data. But when you talk about the unsupervised learning can be thought as a self-learning, where you don't need to supervise the model, where the model have to work on its own to discover the information. Like I have given you the data of some employees of a company, and you don't know about the employees, you don't know about the like which employees fall under which category. You need to group out them according to their performance. So what we are having, we have only the features, we don't have the output label. Okay, we only have the features, that is according to those features we cluster the data into the group. So clustering is basically the method of identifying similar group of data in data set is called the clustering. We just want to find out the similar patterns. In simple terms, you can say we just want to group the data based on the similarities. Right? And actually we use unlabeled data in the clustering. Like in the supervised machine learning, we use the labeled data. But in the unsupervised machine learning, we use unlabeled data. Okay? And clustering algorithm is a part of unsupervised machine learning. Let me tell you with the help of the example. Like a company such as Amazon, Netflix, all group their customer on the basis of their interest, on the basis of their history, search history, and then they will invite their customer to buy their product. And if you go to any mall and any supermarket, you can see there items are arranged according to their customer need. So similar item always put together. So items arranged in the mall, in sales and in marketing to group their customers. Are you getting the things? Basically, we have different type of clustering. I don't go into the more theory like overlapping hierarchy, all these things. I just want to tell you the key mean clustering. That is the one of the type of unsupervised machine learning. Okay? So key mean is the popular example of unsupervised machine learning. And we will do the implementation of this key means algorithm. So there are the certain things to understand the key means is, first of all, you will get the some data points. Like here you can see this diagram, you can see this picture. We have different data points. And in these data points, we have segmented, we have grouped these data points into three classes, three groups. So this purple one is one group, yellow one is one group, and this blue one is one group. Right? And you can see there is one bigger point, that is the centroid of particular cluster. Okay? So every cluster will have some centroid. So you can say the more point in the broadly, you can say K-mean is an unsupervised learning algorithm, and K-mean works by grouping some data points together in an unsupervised fashion. And what we will do in this algorithm, it groups the data that have the similar values, put that together by measuring the Euclidean distance between the data points. Like here these three groups, initially they all have the same color. And when we apply the k-means algorithm, we categorize these into the three groups according to their measuring the distance, that is called the Euclidean distance we are using here. Okay? So we follow the certain steps in the k-means algorithm. I can tell you the steps. This is the implementation part. This k-means algorithm steps you can see here. K-means is one of the simplest algorithm steps for the k-means. What we need to do, first thing, the step 1, we need to specify key, the number of clusters. Randomly we select the number of clusters initially. But for selecting the number of cluster, what is the number of cluster? We just want to segment our customer either into 2 groups, into 3 groups, into 4 groups, or into 5 groups. It depends on us, so we can take any number. And the best way to choose the cluster is using the elbow method. I'll tell you in the later step what is the elbow method. Okay? And then This is the first step. After that, we will calculate the distance between each data point and cluster center. We tell the three centroid three cluster we want to do, and randomly we select the cluster centers. Like 3 centers we randomly select. After that, we calculate the distance between each data point and cluster center. You can say we assign the each data point to the nearest centroid. Like here we have done. You can see from this graph, suppose we have taken these 3. Initially we decided we want to cluster into 3 groups. After that we have taken 3 centroids. Okay, and then from this centroid we will distance off every point, and the point which are near to this centroid will fall under the group of this centroid. Similarly, the points which are near to this centroid will fall under the group of this centroid. This task we have done one time. After that, what we will do? We will recalculate new centroid for every cluster. Like this is one cluster. This is one cluster. This is one cluster. From all these points, we again recalculate the center. The center may shift from this point to here. And this center may shift from this point to here. And this center may shift from this point to here. Again, we will reassign the data point to the new centroid, and we will repeat these steps until our centroid is stable. Okay, so you can see here the algorithm steps we have written here, and these 6 steps we need to do. For doing the implementation part, we will use here sklearn algorithm, and that will do all these steps automatically. You don't need to worry about these, but you should know the concept. Okay? Are you getting the guys? What is the clustering? I have provided you the notes also. After the class, just revise the notes one more time and just give me a quick confirmation. Are you getting the things or not? Like, what is the clustering algorithm? I just try to tell you the what is the clustering algorithm. Okay? In the next step, we will understand the implementation of k-means algorithm as well as elbow method. Okay? So I can write here the step 4 k-means algorithm we have already done. I can give this link to you guys. I have already provided you. You can simply put this link. So step 4 we have completed. From the 8 steps, we have completed the 4 steps. Now come to the next step, that is the understand how to obtain the optimal number of clusters, the elbow method. Step 5. Elbow method. Okay. Elbow method is to select the optimal number of clusters. Like in the k-means, I told you initially we take the number of clusters randomly, like I have taken 3 or 4, whatever your choice. But there is an algorithm that is called the elbow algorithm, and we can use this algorithm to find out the optimal number of clusters. Okay, so elbow method for optimal value of k in k-means algorithm. You can go to the Google and you can find the elbow method. And this is the first Wikipedia link you can see here. In the cluster analysis, elbow method is a heuristic used in determining the number of clusters in the dataset. Okay, and the graph is like this. So what we will do here, basically, we know the k-means algorithm till now. Okay, and in the elbow method, we will experiment with the different number of clusters. Suppose in your algorithm you are taking initially 3 cluster, then 4 cluster, 5 cluster, 6 cluster. Like this we will take a different number of clusters and then we will plot a graph. And in that graph you can see there is a graph like the elbow, and the point in the elbow, the turning point, when our graph is going to the linear, then it becomes the optimal value. Like this graph, this is the optimal value. After this you can see this is the straight linear kind of, but the certain change. So number of clusters, we will take different number of clusters and then we will calculate the distance. Like I can explain you, this is the clustering algorithm. Okay, and we have taken the 3 clusters. You can see this output. We have taken number of clusters as 3. Suppose I'll take the number of clusters 4, then there would be in the output 4 classes. What we will do, when you are taking 3 means you will measure the distance of every point from this cluster, measure the distance of every point and then the sum of the distance. Similarly, measure the distance of every point in this cluster and measure the distance of every point in this cluster, and then sum of all the distances. This is for the 3 clusters. Similar thing we will do if we suppose we are making a single cluster. I'm very lazy, I just don't want to create the multiple cluster. I just assume all the data points fall under a single cluster. So what we will do, the distance from the centroid, like here is a centroid, suppose this point is a centroid. If you calculate the distance of every point to this centroid is more, like this orange one, if I'll calculate the distance of orange one with this yellow point, this is bigger than if I calculate the distance of this green one with the yellow. Green one with the yellow is less, obviously. So if number of clusters is less, then the distance is more of every point. And at the end we need to calculate all the distances and we need to make the graph. Don't worry, in the implementation you will understand the things in more clearly. Like I can open my Paint and I can explain you the things. The elbow method. Suppose we have 10 points is equal to 10, and the case 1 I'm taking a single cluster, and in the case 2 I'm taking 2 cluster, and case 3 I'm taking 3 clusters. Okay, so in case of single cluster there is only one centroid. So I need to calculate the distance of every point to centroid. Okay, so 10 points and I have one centroid. So obviously I'll get the 10 distances, but every point have more distance from this centroid. So suppose I'm getting sum of distance is 1000. Similarly, if I'll divide the 10 points into two clusters, means two centroid, like 4 data points in one cluster, 6 data points in one cluster, 4 in one and 6 in another. Now you can see the data point near to in the second cluster is near to second centroid, and the data point in first cluster are near to their centroid respectively. So if you calculate the distance, like these 4 points distance from their centroid and this 6 point distance from their centroid, always if you do the sum, it will always less than this 1000, and this is around 600. Similarly, if I'll divide the data into 3 clusters, then when you calculate the distance, this is more or less like near equal to 300. Now we will do the things like this, and at the end we plot the graph in distances and number of clusters. So whenever the elbow point, we will select the optimal key. In our case, we will see the implementation part also. This is only the concept. Okay? This is the theory part I just want to tell you. Okay? Now come to our practical part. So step 5, elbow method, I explain you in the theory part, but the practical thing we will do now. Okay, now we will do the implementation of k-means and elbow method. Okay, so let's see first scale our data. We have not done the standard scaling. Before feeding your data to any machine learning algorithm, you need to scale your data. So scaler I have already imported, that is the standard scaler. I'm using here the standard scaler. Scale data. Scaler is standard scaler. I have imported in the second step, and then normalize the data. Credit card df underscore scaled. Now I'm scaling this data using the scaler dot fit underscore transform. I need to pass through the function, and here credit card df. Now my data is scaled. Okay, I can check the shape of this data. I can give the small name is S. Credit card scale S dot shape. Shape, you can see we have 8950 rows and 17 columns. And now we can print the data. Okay. Credit card df underscore s. This is scale data. You can print, and you can see the range of data is now like in between -1 to 1. So lower range always works with the machine learning algorithm, always works with lower range data. So we always normalize our data in any machine learning algorithm. Okay. Now we will apply the k-means algorithm. So how to apply the k-means algorithm? We have imported already the k-means. And I can show you the elbow method output here. Like I can take a variable scores is equal to empty. And then here I'm taking the iterations, like I'm taking the 20 iterations. 20 times I just want to run this. Like you can take the iteration whatever you want. Here I'm taking the 20 iterations, range underscore values equals to range 1 comma 20, and for I in range underscore values, I'm running a loop, and here I'll apply the k-mean. K-mean is equal to k-means, and inside the k-means number of clusters I'm passing. First I'll take 1, then 2, 3, 20, till the 20 clusters I'll take. So n underscore clusters equals to I. Are you getting the things? I just want to plot a graph for the elbow method. So I'm applying the k-means algorithm here, and initially I'm taking number of clusters 1, then 2, 3 till the 20. Okay, and then k-mean dot fit our data. Where we have our data, credit card underscore df underscore s, scale data. Okay, and then inside the scores we are going to add the distance. We want to plot the two things. One is the number of cluster and the distance. So how to calculate the distance? In the k-means algorithm we have one function called the inertia. Inertia will calculate the distance of every data point from centroid. So score.append, and here I'm writing k-means dot inertia. You can see like sklearn k-means. You can see the documentation here. This is the good documentation, and like in details about the k-means, what is the k-means function and different parameters. And you can see if you scroll down, there is the one parameter called the inertia. Inertia, it's sum of square distance of samples to their closest cluster center. So the distance, for that I was talking the distance of every point from their centroid. That we will use in the elbow method. Okay? So what I will do here, I'll plot here. I'll plot the graph between scores matrix and the clusters. So I can go here and outside the loop plt.plot, and then you can see score comma bx. I'm taking simple bx. Score is not defined. Scores, I have taken scores. Oh, sorry. k-mean. I need to write here k-mean. These are the typo mistakes. Now it's running and it will plot a graph. It will form a elbow kind of graph. And you can see this plot. And from this plot, this is kind of elbow plot, and you can observe like near to 7 or 8, it is a turning point, a linear kind of plot. Right? So from this we can observe that 7th or 8th clusters seem to be forming the elbow of the curve. Like from the 4th cluster, you can see it seems to be forming the elbow, but the value near to 7 and 8, it's changing linearly. So we can say here the best value for this data set we can choose for the number of cluster is either 7 or 8. Okay? Guys, can you give me a quick confirmation? Are you got the elbow method or k-means algorithm? For the k-means implementation, you don't need to worry about the steps. It will automatically do the things. We need to use only the k-means function, and inside the k-means, we need to pass the number of clusters. And after passing the number of clusters, we need to fit our data. K-mean.fit credit, this is standard scale data, final data which we are using, and here we don't have train and test data. Like someday if you already work with some machine learning algorithm, so there is always data we have divided into training and testing, but in the case of clustering we have only the training data, we have only the data, we don't have labels. So we need to pass the complete data here. We don't need to divide the data into two parts. We need to pass the complete data here, and we will predict the labels. Okay, we are almost almost done. We need to do the little bit things more. Like we have covered the till now the data cleaning part, and then we have covered the k-means, elbow method, all most of the things we have done. So till now I'll just giving you the 5 minutes. You can ask the question whatever we have covered. Otherwise I'll give you the one question, like you can change this activity. Just note down a question like let's assume our data have only first 8 columns. Like here we have 17 columns data, and suppose we have only the 8 columns. Then what is the optimal number of cluster we will take? Like we don't have the complete data, we have only the first 8 columns. Then what the number of clusters we need to take? I'm writing the question for you. Meanwhile, you can ask the question from me also. Suppose we have our data only having first 8 columns. Then what is the optimal number of clusters? Okay, you need to modify the previous code only. Can anyone give me the answer? Basically, what we need to do here, we need to take the data only the first 8 columns, not the complete 17 columns. We need to modify our code. Okay, I can write here the answer. Basically, what we will do here, the code which we have used here, this code. Here I'm taking the credit card underscore df underscore s. I'm just copying this code, complete code. Okay. And I'll paste this code, and in place of credit card df underscore s, the complete data set, I'll put here, I just want all the rows, but the column only, I want the first 7 columns. Okay, so I want only the first 7 columns. So here I'll just modify this part only, and then you can see the output is different. Like I want all the rows, colon means all the rows, and then colon 8, I want first 8 columns. In the x-axis, colon means all the rows. In the y-axis, colon means it starts from 0 and will go till the 7. So 0 to 7, it will take only the first 7 columns. And I can run this code. And you can observe from the plot, just it's plotting yeah, you can see from near to 4, 5, elbow is changing. The turning point is near to 4, 5. Like last plot and this plot, some difference. So in this case, we can take the best choices 4 to 5. Like you can take the 5 clusters. Okay, now we will do now the next task is we will do the apply the k-means algorithm, and we will see the labels. We will segment the customers. So how many tasks we have done? Step 5. The next is step 6. Apply k-means algorithm. Okay. We are going to implement the k-means algorithm and going to predict the label for the customers, and our main motive is we need to divide the customer into different categories to do the targeted ad. So how to apply the k-means algorithm? To apply the k-means algorithm, we have already imported k-means. So k-means is equal to k-means 7. I'm taking number of clusters 7. Okay. N underscore clusters is equal to 7. And k-means dot fit. Here I need to pass my data. Credited, credit card, df underscore s. I need to fit the complete data, scale data. After this, I'll go to the label. Label is output label, like in which category a particular record is fall. Like k-means dot labels underscore. Okay. This is the algorithm, k-means algorithm. Now I can check the centers, center point, and then I can simply check how to work with the what the label we are getting. We will compare with the actual data. Okay. So you can print the labels here, like what our data is getting the labels here. Labels and centers. There is a property inside the k-means is one is the labels and another is cluster centers. K-means dot cluster centers and dot shape. You can see cluster centers, we are getting the 7 centers. Obviously, we have provided number of clusters as 7. So you will get the 7 centers. And every center have 17 columns. Okay. Now we will make a data frame of cluster centers. We will make a data frame of the cluster centers. Like we will provide cluster centers to a heading, column name. So what I will write here, cluster underscore centers is equal to pd dot data frame, and inside the bracket I'm passing data is equal to what the data I'm providing here, cluster centers. K-means dot cluster underscore centers. Okay. Comma, column name, headings, what I will provide, the column name which is of actual data column name. columns is equal to credit card underscore df dot columns. And now I can print cluster centers. Let me explain you one more time, just wait. What I'm doing here. These are the 7 center points. You can say 7 centroids of the clustering. And every centroid have 17 columns. So what we have done, we have made a data frame. And we have provided the column names here. To see that clearly. So you can see here the code. pd.dataframe, it will create a data frame and data is equal to what data we are feeding here? K-means dot cluster centers. This data we are providing. Comma, columns. What the columns we are providing? The actual data column names. So columns is equal to credit card underscore df dot columns. Are you getting? And then we are printing the cluster centers. Okay, so these are the cluster centers we have written here. Next is, like, these are the cluster centers, but we just want to see the output in the form of our balance frequency, purchases, and like installment purchase, cash advance. These are the normalized values you can see, but we want to see the values into the actual number, like balance is 800 something, 5000 something, 700 something, but these are the normalized value. I just want to revert back, like during the standard scaling I have done the fit transform. I just want to do the inverse transform here. I want to see the actual values, okay, so that I can understand the things, because from the center point I can understand the category of customers. Like I told you, we have broadly we can categorize 4 type of clusters: transactors, revolvers, VIPs, and low tenure new customers. So first we will inverse transform the centroid points. So what we will do, we have our data inside cluster underscore centers. We will inverse transform cluster centers. Okay, so cluster centers, with the help of standard scalar, we can reverse transform. Ashish is asking, ma'am, can you explain again? Just wait, Ashish. After completing this step, I'll recap the things. Okay, I'll recap the steps. Which step you want to explain me again? Like I can go back, apply k-means algorithm. Till that what I have done, I just clean my data and then alpha method I have applied. Now I'm just applying the k-means algorithm. In the k-means algorithm, I'm taking the k-means function and then number of clusters I'm taking here 7. Okay, k-means analysis. The elbow method always provide you the optimal number of clusters. So from the elbow method, we got the optimal number of clusters. In our case, it's 7 to 8. So I'm taking here the 7. K-means is a function for applying the K-means algorithm. And I'm passing here the 7 is number of clusters. So I just want to apply the K-means algorithm with the 7 clusters. Then K-means, inside this K-means, I need to pass the data. So K-means dot fit, and here I need to pass my scale data. So credit card underscore DF underscore S. This is my final scale data that have shape 8950, 17. So I'm passing this data to K-means.fit. Basically, what it would do, it generate center points, like 7 center points, and labels for every row. Like we have 8,950 records. So every record will assign a label. Either this record fall under the cluster 1, cluster 2, cluster 3, like this, cluster 7. So 8950, every row will have one label. And that labels you can see with the help of K-means.labels underscore. So K-means.labels underscore, we are storing this into a label variable, and you can print here label. And you can see here the output. You will get an array. Array shape is 8950 into 1. So every data point will got the one label like 1 to 0 to 6. 7 cluster we have taken here. So 0 to 6. Similarly, these are the labels we are getting for every data point. Similarly, we are getting the cluster centers, like 7 cluster we want to make. So obviously we will get the 7 centers, and every center with this as many columns as many we have in data. Like we will get the centers with the 17 columns in this case. So K-means dot cluster underscore centers underscore dot shape, you can say 7, 17. After that, what I'm doing here, I'm just making a data frame of cluster centers. I just want to check the cluster centers values. Like first cluster, if it have the center values, something balance, frequency, purchase, these values. So I can analyze the records which are near to these values will fall under the category of cluster 1. Right? So I'm making a data frame, pd.data frame, and data is equal to K-means.cluster underscore centers underscore comma columns. Okay? Okay, now the next thing is, these are the values you can see for the cluster centers, but I cannot understand the things. What's the happening here? I'm not getting these values because these are the normalized values. Before proceeding the clustering, I have normalized my data because machine learning algorithm works good with the normalized data. But for seeing the output, I just want back my data. I want actual data in the form of actual data form. So what I will do here, I will do the inverse transform with the help of standard scaler. Okay. So the next thing I'm doing here, inverse transform. For doing the inverse transform, I need to use the function of standard scaler is inverse transform. So I'm writing here cluster underscore centers. Cluster underscore centers is equal to scalar. Scalar is a variable that having standard scalar. So scalar dot, previously we have used fit transform. Now I'm just going to use inverse underscore transform to get back the data. Okay, to perform the inverse transform in order to understand what these numbers are actually. So here I need to pass the cluster underscore centers. Okay, cluster underscore centers. And then what I will do, cluster underscore centers is equal to, I'll convert back to the data frame. So I can see the output. PD dot data frame, and here the data I'm passing cluster centers, comma, columns I'm passing the actual column name. Columns is equal to credit df dot columns. Okay, and I can print cluster underscore centers. Okay, now I can run this code. See carefully, and now you can see the output. I have 7 points with the 17 columns, but the values now you can see the different. Like balance, I have in the cluster 1, I have balance around 5104. Balance for the cluster 1, I have 103. This can be different for you. Little bit, because the clustering algorithm is not there, give you the actual as it is output, but all the output is near equal. Okay, so you can see here the balance frequency is 0.97, means they are updating their balance frequently. And the cluster 1 balance frequency is 0.37, means they are less updating their frequency, their balance. Okay, so you can see the first customer is like, we can identify from here the type of customers. Like one customer who have less tenure, you can go to the tenure, and this second last is have very less tenure, all other have 11 point something, this have 7. So these are the fourth type of customer, new customer, that have less tenure. Okay, and high credit limit, like VIP customers have high credit limit and highest percentage of full payment. So we can see credit limit, you can see there is one type that have highest credit limit, and corresponding to highest credit limit, you can say the percentage of payment also. Payments also more. So these are the types of customer who are the VIP customer. You can see other parameters also. I'm just taking 2-3 parameters. So I can say the VIP and new type of customer, and the second type of customer was the revolvers who use the credit card as a loan. They may have highest balance and the case advance, but they would be the low payment. low purchase history as well as low payment history and high cash advance frequency. So I can see the low purchase history and case advance frequency are these, and then the low, they would be the lowest balance. Low purchase frequency, na? Purchase frequency. They have low purchase and they also have low purchase. So we can see the other parameter also, na? 2-3 parameters we need to check out. Okay? And with the lowest balance customer are, you can see here, 103. These are the type 1 customers. Lowest balance. They are the more careful with their money. They pays least amount of interest. So these are the type 1 customer. These are the transactor customers. Okay, so you can classify the customers according to these things. Now I can show you labels dot shape. Labels associated to each data point. Shape, I think we have already checked. It's a labels. I have taken this variable, I don't remember. Label, not labels. It's a label dot shape. Label dot shape is 8950. Like every row will assign a label. Each data point is associated with certain labels. And max and min label you can check. Label dot max, it would be 6, and label dot min would be 0. Right? Now we will predict the labels for our data. So y is equal to the label we are predicting from the k-means dot fit underscore predict. And inside this I need to pass our scale data. So credit card df underscore s. And now I can print the y. And here you can see the labels which are assigned to our scale data. Now what we will do, we will put our labels with our data set. So you know our data set is credit card underscore df. And if I'll put these labels in one more column, that column name I'll provide the cluster. So 17 features we already have, and this 18th is the cluster label. So we concat our cluster labels to our original data frame. Okay, so you can see here what I can do. Here I can write credit card underscore df underscore final cluster data, okay, equals to pd dot data frame, or you can take the pd dot concat, and we just want to concat two things. One is the original data, credit card underscore df, comma, pd dot data frame, and inside the bracket I'm passing the labels. So column name I'm providing here the cluster, and the value to this cluster is label, okay, and comma access is equal to 1. Now you can print credit card underscore df underscore cluster, and now I can run this, and you can see here total rows 8950 rows and column is 18 columns. I can scroll the columns. The last column you can see tenure. After the tenure we have cluster column. This column we have added. So this is the cluster label. We are providing the cluster label. Okay. And meanwhile guys, if you are getting the things, we are organizing this type of workshop almost every Sunday, so you can subscribe our YouTube channel so that you will get the notification of all coming workshops, and you can also work as a coordinator so that you can tell to your friends and your colleagues, your college mates, so that they will also get the benefit. So if you want to become a coordinator for our organization, you can give us a WhatsApp, like I can give you the number. Just give me your name and your email ID and your contact number, obviously in the WhatsApp. And if you want to become a coordinator, just write right there, I just want to become a coordinator, so that we will send you all the information regarding upcoming events, and you can share with your friends. And you know, our website have lots of content. Like if you are studying in a university, our website containing all the practical lab solutions and different tutorials. Like you can see the machine learning tutorials, you can see the NLP tutorial, you can see the OpenCV tutorial. All are the working codes you can see here, and you can study the different things. Okay, and like the latest technologies like OpenCV, NLP, ML, you will get the best content here. So the one thing I was telling you to make the cluster, how to make the cluster, we have made the cluster like this. The next thing is we implemented the k-mean clustering. Now we can plot, like we can show the clusters in the form of plot, like we have total how many clusters, and in a particular cluster how many points are falling. For a particular column we can make the plot. or either we can apply the principal component analysis and visualize the results. So first I'll make the histogram of various clusters. Okay? Like you can say the visualization I just want to do. The next step is visualization. I don't remember the step number, but it's last step, visualization, and then the last step is after this we can take the PCA. For this, I'm just going to make a histogram. Histogram of various clusters. So we will run a loop for I in credit card underscore df dot columns. For every column we are going to run, and then inside this we are going to run one more loop for every column we are going to run for every cluster. So for j in range 7, because our cluster is 7. Here I can give the figure size so that it won't overlap. And also mention your college ID in WhatsApp, college name. plt.figure fig size I'm taking here equals to 35,5. plt.subplot one comma 7 comma j plus y 1. And then here the cluster is equal to credit card df cluster. We are going to use the credit card cluster df cluster, and then credit card df cluster, this cluster column, last column. Cluster column is what? It having the label equals to j. Like same clusters data we are making a1 histogram. So cluster of I dot hist means equals to 20, and then plt dot title you can give, and otherwise you can leave it. plt dot show. I just want to show the histogram. Basically clusters histogram, you can see the output. Let me show you. Like how many cluster we have? We have 7 cluster for every column. So you can see, like for every column, how many data points fall under this cluster 1, cluster 2, cluster 3, like this. Like we can understand first plot. This first one is for the balance and for the cluster 0. So you can see the cluster 0 balance is like this. Like in the cluster 0, some persons have balance near to the, like 1400% have balance around something 11, and then 200% having balance around 2000. So like this we have different for every cluster we have histogram. For the cluster 1, this is second plot is for the cluster 1 balance. So cluster 1 balance, cluster 2 balance, like this for the cluster 6 balance. Similarly, these are the balance, and then come to the second plot, the frequency. For the cluster 0, more frequencies for 1, near to 1. And for the cluster 1, similarly 2 is also similar, and you can see for the cluster 5th cluster frequency is different, and third cluster also different, and this fourth cluster is almost everybody is conversion rate is more, like balance frequency they are updating frequently. So like this for every column we have plots. Okay. The last task is you can apply the principal component analysis, and you can see the result in the form of principal component analysis, because that would be the more easy for you to understand the output. To understand the output, we will apply the principal component analysis. Principal component analysis. First of all, I'll tell you what is the principal component analysis. Okay? Basically, in the principal component analysis, we reduce the dimensionality. Like here we have more columns, but we just want to reduce the dimensionality. So what we will do, we make some important components, like principal components. We don't use all the components, we will make some principal component, but we don't want to lose the details also. So you can say PCA is an unsupervised machine learning algorithm, and PCA performs dimensionality reduction. And like basically we take the components that are composite of all the features. Like we can take here, just let me explain you, just wait a minute. Suppose here we have 17 features, but we want to convert these 17 features in 3 or 4 features. So PCA will perform dimensionality reduction, attempting at keeping the original information unchanged but reduce. So what we will do, we will find some new feature components. Like here we will use the PCA. We already imported the PCA. We just do the implementation of PCA. PCA is equal to PCA, and inside the PCA I need to pass the number of components. So n underscore components, I'm taking here only the 2 components I want. Okay, I want 2 principal components. So here principal underscore comp, I'm taking PCA dot fit transform over my scale data. PCA dot and now I can print my principal components. It will find 2 principal components. So we will create a data frame with these 2 components, and then we will visualize our data with the help of these 2 components. So data frame PCA underscore df is equal to pd dot data frame data is equal to principal component, and column name I can give any column name. Columns is equal to, I'm taking PCA1 and PCA2. PCA1 comma PCA2, and I can print PCA underscore df, and you can see the output PCA1 and PCA2. So 2 feature parameter I got it. Now what I will do, I will concat the cluster labels to the data frame. My data frame is PCA data frame, and I'll concat the cluster labels with this. This is I'm doing just for the visualization part. So PCA, so that you can get the better visualization, is equal to pd dot concat, and here what I will take PCA underscore df dataset inside the PCA, and then I can take pd dot data frame, and inside the bracket I will pass the cluster. This is the name of the column. I need to give into the single quotes colon, and my variable I think label. Okay, and I need to provide here x is equal to 1 and PCA underscore df I'll print, and you can see the output here, the principal component along with the one more column, that is the cluster, that is basically cluster label. Now I can visualize better. By using the colors. So I just want to plot plt.figure figure size. I'm taking a bigger one like 10, 20 or 10, 10 is enough. Ax is equal to SNS dot scatter plot. Here I'm taking the scatter plot. And inside the scatter plot, x I'm passing the PCA1, y is PCA2. X is equal to label PCA1 and y is equal to PCA2. And then the color hue I'm taking here cluster. And then the data I'm taking here, data is equal to PCA underscore df. And now I can give the color. How many color I can give here? As many labels you have. Like I can give the color palette is equal to PA. This is something different. PA L E this, and I need to provide here the 7 colors. As many clusters, you need to provide the colors: red, green, blue, yellow, pink, 5, gray, and one more I'll give the purple. Okay, and now I'll plot it plt.show, and you can see the output, and this is the batter. These are the cluster colors, cluster 0, 1, 2, 3, 4, 5, 6, and these are the points which are falling under the category. Like yellow points have one cluster, green points have one cluster, and red is one cluster. Okay? Yes guys, this is almost we have done, like we have completed our project. I think you got it. Like what we have done here, we segmented the clusters, we segmented the customers basically. Yes, Mohitan, almost I just want to conclude the session. What I have covered till now, the things which I need to cover is already covered, each and everything. So basically I can conclude the session by telling you the steps what we have done. Okay, like you can go from the start and you can see the conclusion. Like initially we understand the problem statement, what we want to do, and then we have imported all the important libraries and data set, and we have cleaned our data, we have played with our data, we have seen the insights of our data, we dropped some column, we have replaced some blank values. All these things we have done with our data, After that, in the step 3, we visualize our data set. How our data set is look like. Okay? And we have done the standard scaling of our data also. Okay? And after this, we have seen the correlation of our data, and then we have studied the theory part of k-means algorithm and how the ALBA method works, how to select the optimal number of clusters, and then we have applied the k-means method to our dataset, our standard scale dataset, and then we have got the labels, predicted labels to our data, and then we have done the visualization of our data. The visualization is little bit difficult, so we have applied the PCA, principal component analysis, and with the help of this we have visualized the data in the form of scatter plot. So we applied the principal component technique to perform dimensionality reduction and data visualization. Okay guys? From my side, each and everything I have tried to cover you, and I advise you guys please change the number of clusters and the number of features in your data set and try to apply these things. Again, you will get the things more better. Okay? And if you have any query, you can ask me now. And after the class, you will get the recorded session, so you can revise the things because it is a big project. You need to understand each and everything very carefully. So certain things I have covered fastly, so you guys can replay the video and you can listen again. And if you like the video, if you like the workshop, then you can hit the like button, you can subscribe the things, and subscribe our channel, and you can recommend to your friends also. And one more thing for the attendance, kindly mark your attendance last time. So we have provided you the Google form, you need to mark your attendance, so that we will, and you need to do after this session, below this video you need to comment the session summary and how was your how was your experience and what you have learned in this workshop. Below the video you need to write in the comment. So after viewing your this comment below the video and your attendance 2-3 times we have taken, so we will verify your attendance and then you will get your certificate over your email. Okay guys? And it was the nice experience. I hope see you in the future for the next upcoming assignments and the workshops. For the last 5 minutes I'm here, you can ask any queries. Mark your attendance. This is mandatory guys, otherwise you won't get the certificate. And stay tuned with our channel, so you will get more workshops in the future. Nowadays we are in the pandemic situation, we are at the home, we won't go colleges, so you have lots of time, you can utilize this time to get the more knowledge. Okay guys, thank you so much. It was the good experience with you guys.